तो एस्पिरेंट सबसे पहले ये बताइए कि गवर्नमेंट जॉब होता क्या है।
गवर्नमेंट जॉब ना रिलेशनशिप की तरह होती है, जो जो रिलेशनशिप डिमांड करती है वो सब प्रिपरेशन भी डिमांड करती है।
जैसे कि कांस्टेंट एफर्ट्स, अनडिवाइडेड अटेंशन, लॉयल्टी, जीरो डिस्ट्रैक्शन।
गुड। और जैसे सिर्फ प्रपोज कर देने से रिलेशनशिप कंप्लीट नहीं होता है, वैसे ही सिर्फ फॉर्म फिल कर देने से सिलेक्शन नहीं होता है।
सर मोस्टली रिलेशनशिप में या लव स्टोरी में लव गुरुज होते हैं, वैसे एस्पिरेंट के लिए भी प्रिपरेशन गुरु तो होना चाहिए ना।
हाँ बिल्कुल होना चाहिए। और आपकी प्रिपरेशन का गुरु है सुपर कोचिंग, और आपके गवर्नमेंट जॉब के प्यार को सफलता में बदलने के लिए सुपर कोचिंग लेकर आया है सिलेक्शन मेरा प्यार सेल, जहां पर आपको सभी सुपर कोचिंग पर मिल रहा है अप टू 90% ऑफ। तो अभी जाइए इस ऑफर का लाभ उठाइए।
Hi, good evening everyone. This is Shefali Ma'am, and in this session we'll be discussing few more questions from Unit 2, Digital and Computer Architecture. तो कल हम लोगों ने कुछ questions discuss किए थे. In this week we will be covering the questions from Unit 2 because we are covering the concepts of Unit 2 and I hope कि आप लोगों की revision अच्छी चल रही होगी. तो थोड़ा सा और revision को push करने के लिए we are having this series. Very good evening, Arun. Good evening, Nitika. Good evening, Shikha. Good evening, everyone. So, are you all ready? All right. So, without wasting our time, let's quickly jump to the first question. In this question, it is asking for the order of schema. So, you are given with some string and you are supposed to find out the order of schema. अब ऑर्डर ऑफ स्केमा क्या होता है, पहला क्वेश्चन ये है. अगर हमें ये समझ में आ जाए ऑर्डर ऑफ स्केमा क्या है तो डेफिनेटली विल रिटर्न दैट. सो ऑर्डर ऑफ स्केमा is nothing but it's the fixed number of bits in some string. Okay, so schema is order of schema is the fixed number of bits. Okay, for example, if I take the first string, you are given with question mark 10, question mark 101, question mark. So in the string, how many fixed number of bits are there? 1, 2, 3, 4, and 5. So for this, order of schema is 5. Order of schema is 5. Similarly, if I take the next one, 0, question mark, and 1, how many fixed number of bits are there? For this one, fixed number of bits are 2. So we can say that for this string, the order of schema is 2. So we have to find out the order of schema for the first string, that is 5. And for the second one, it is 2. So answer comes out to be 5 and 2 respectively. That is nothing but option 2, 5 and 2. Okay. Next one. So which of the following binary codes for decimal digits are self-complementing? Anyone having any idea that what is the self-complementing codes? Very good evening, Priyanka. What are these self-complementing codes? We have talked about the gray code, we talked about 8421, 2421, ये सारे weighted codes हैं, but इसमें से self-complementing code कौन सा होता है? Any idea? Which of the following binary codes for decimal digits are self-complementing codes? So let us consider the example. I'm taking the decimal codes. I'm taking the decimal codes. Decimal means आपके पास distinct digits होंगे 10 because decimal means base 10. So distinct digits are 0, 2, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the distinct codes, decimal codes. Now for this, I'm writing the excess 3 code. XS3 code. XS3 will be, XS3 is nothing but जब आपके पास bits जो भी कोड है उसमें +3 करके you are writing that in binary. So first of all, अगर आपके पास 10 combinations है तो हर digit को हम कितनी bits के साथ represent करेंगे? In order to represent 10 bits, 10 digits, how many bits are required? No idea? That's okay. 4, D and A. Okay, let's check out that. So each digit will be represented with 4 bits. XS3 means, नाम से समझ में आ रहा है, +3 करके आप इसको बाइनरी में लिख देंगे. 0 + 3 is 3, so it becomes out to be 0 1 1 3. 1 + 3 is 4, so this is 0 1 0 0 4 5. ऐसे लिखते हैं XS3. 6 7 8 1 0 0 0 1 0 0 1 1 9 10 11 12. ओके, सेल्फ कॉम्प्लीमेंटिंग कोड होता है. कॉम्प्लीमेंट का मतलब होता है कि 0 बिट को कन्वर्ट कर दिया 1 में, 1 इज कन्वर्टेड टू 0. अब यहाँ पे देखिए, मिड से, फ्रॉम मिड, टोटल डिजिट्स कितने हैं आपके पास? 10 डिजिट्स. मिड मतलब 5. आफ्टर 5 कोड ने खुद को कॉम्प्लीमेंट करना शुरू कर दिया. सेल्फ कॉम्प्लीमेंटिंग कोड होता है कि अगर आपने कोई भी कोड लिया है उसका कॉम्प्लीमेंट भी आपके पास एग्जिस्ट कर रहे. सो 0 1 1 1 का कॉम्प्लीमेंट क्या होगा? इट विल बी 1 0 0 0, सो इट इज प्रेजेंट हियर. 0 1 1 0, its complement will be 1 0 0 1, it is present here. 0 1 0 1 1 0 1 0, it is present here. Similarly, here you can see, excuse me, excuse me guys, 0 0 1 1 means it will be 1 1 0 0 0. So all the complements are available. So we can say that XS3 is a self-complementing code. ये तो manual तरीका हो गया कि आप self-complementing code check कर रहे हो. Otherwise what we'll do is self complementing. यहाँ पे अगर decimal है, decimal के लिए आप कौन कौन सा complement find कर सकते हो? We have talked about this. What all complements can we calculate for the base 10? What all complements can we calculate for base 10? It's 9's complement and 10's complement. 9's complement. So here for every number we will be calculating the 9's complement. तो उसके लिए क्या करना है? आप सारे के सारे bits 9 लोगे and उसमें से you need to subtract n. N is some number. Okay, so this complement, this should be available in the result. So n is representing the individual bits. I don't have much space on this slide. So anyways, individual bits. Individual bits hai, and now you are finding 9 minus n. For example, if I'm finding for a binary of let's say we want to find the self complement for 4, so it will be 9 minus किसका complement find कर रहे हैं? 4 का. तो this means that जो भी इसका complement आएगा, जो भी result आएगा, complement will be for 5. Similarly, if I am subtracting 9 minus 2, that comes out to be 7. तो 2 का जो complement है, 2 का complement will be resulting for the 7 in the binary. You get this? Make sense? So I'll be representing this in binary form. In binary form. 1, number 1 का complement कहाँ पे reflect होगा? 9 minus 1 is 8. So 0 1 0 0, तो इसका complement 8 को आप XS3 में कैसे represent कर रहे हो? It will be 1 0 1 1. It is 1 0 1 1. So we can say that XS3 is the self complementing code. इस तरीके से आपको बाकी के कोड्स चेक करने हैं. फॉर एग्जाम्पल, वी आर चेकिंग फॉर 8421 2421 8421 2421, ये भी वेटेड कोड्स हैं. सो लेट्स टेक 2421, 8421, or let me start writing for 8421, otherwise it will go behind the image. Let me see if we have, okay, I'll write that on the next slide. So let's check here for 8421. So here I'm taking the decimal digit 8421 and 2421. So here I'm taking all the decimal digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 8421 will be, this is 8421. यही codes दिए आपको 8421 and 2421. Exactly, very good Arun, you got it. So 2 plus 4 plus 2 plus 1, that is equal to 9. So definitely this will be a self-complementing code. एक तरीका आपने बताया, दूसरा तरीका जो अभी मैंने बताया है चेक करने का, you can also follow that. If you don't know this approach, so 2421 is also a self-complementing code. You can put the values here. So this is 0000, 0001, 0010, 0011, 0100, 0101, 0110, 0111, 1000, 1001. So is it self-complementing code? This is not self-complementing code. Okay, check for 2421. 0 means all the bits will be zeros. 1 is 0001, 0010. Then is for 3, it is 0011. 4 is 0100. Now check for 5. Because if it's a self-complementing code, एक अभी simple तरीका आपको बताया है. If it's a self-complementing code, so 9 minus 4 is 5. Check karo for 5, are you getting that code? So it is 0100. Are we getting 1011? Is it representing 5? 2 plus 2 plus 1, this is representing 5. Similarly for 6, it is 1100. Is it representing 6? Yes, it is representing 6. So this way you will be getting the self-complementing codes 0, 1. Then is 1110, 8. Then is 9. All the bits will be 1. Moreover, you can directly check it from here. 2 plus 4 plus 2 plus 1, that is 9. So we can say that 2421 is also a self-complementing code. Similarly, you can check for the other options. So XS3 gray code is not a self-complementing code. So self-complementing code is 2421 and XS3. These are the self-complementing codes. So the correct answer comes out to be B and C. That is nothing but option 2. So correct answer for this question is it's option 2. Make sense? Is this clear? Easy, comfortable? If yes, then let's move on to the next question. Yes, option 2 is the correct one. All right. Next one. Octal equivalent of hexadecimal number. So you are given with the hexadecimal number. आपको octal equivalent find करने हैं. What are the different ways? Different तरीके हो सकते हैं. How will you be finding the octal equivalent of hexadecimal? So this is nothing but this is basically hexadecimal to octal conversion. आपको एक hexadecimal digit दिया हुआ है, एक hexadecimal number दिया हुआ है और आपको इसे octal में convert करना है. What are different methods? One method is hexadecimal to binary convert करो and then binary to octal. Other method is hexadecimal to decimal convert करो and then decimal to octal. Anyhow, we have covered hexadecimal or other number system to decimal and decimal to other number system. जब कुछ भी समझ में नहीं आए, anyhow वो तो backup method है ही है. Okay, so it's up to you which method you want to use. और definitely हमें मालूम है base 16 means different digits जो आएंगे आपके पास, that is 0 to 9 and A to F. A, B, C, D, E and F. A is representing 10, B is representing 11, C is representing 12, D is representing 13, E is representing 14, F is representing 15. So I have discussed two methods. Method 1, आप hexadecimal to binary convert करोगे and then binary to octal. This is one method. Choice is yours. Other method is method 2. Convert this number from hexadecimal. You are given with the hexadecimal to decimal. Convert this to decimal and then decimal to octal. So this is nothing but other base to decimal conversion, other base to decimal, and then second step में आप apply कर रहे हो decimal to other base. Very good. So Arun got it right. So 1 is the correct answer. Let's solve this with both the methods. First method, I'm converting this to binary. So hexadecimal is given as D dot C. This is given in hexadecimal. I'll be representing this in binary. Hexadecimal number is given to you. I'm going to convert this to binary. बाइनरी मीन्स हर एक डिजिट को आप 4 बिट्स के साथ रिप्रेजेंट करोगे क्योंकि हेक्साडेसिमल है, दैट इज बेस 16. 16 is nothing but 2 raised to power 4. So each digit will be represented with 4 bits. D, that is 13. So represent D with 4 bits. It is 12 plus 1, 13. Then C is 12. So it is 1, 1, 0, 0. I've got the binary. Now from binary to octal. Octal means base 8. Base 8 means each digit needs to be represented with, each digit will be represented with 3 bits. That means we need to form a group of 3. Each digit is represented with 3 bits. I'm providing the detailed solutions ताकि आप बाद में भी जब भी रेफर करो तो आपको कोई प्रॉब्लम नहीं आए. 3 bits. But एग्जाम में obviously हम इतना सब नहीं लिखते. So here I'll be forming the groups. कहाँ से start करते हैं? Always from the decimal. So 3 bits, 3 bits. एक ही आ रही है तो extend कर दो. Add zeros. Only one bit is coming up, so add zeros. So this is representing 1. This is representing 5. Dot 110. This is 6 and this is 0. So this is the result in octal. That is 15.6. So answer is option A. This is using method 1 जब हमने सब binary में convert किए. Option 2. Method 2. Convert given hexadecimal to decimal. Can you tell me that what is the decimal for D dot C in decimal? So this is nothing but this is in hexadecimal. So on the basis of the position, we have to multiply this. This is position 0 and this is position 1. So this comes out to be the D is nothing but that is 13. 13 into 16 raised to power 0 plus C is 12. 12 into 16 raised to power minus 1. So 12 divided by 16 is 3 by 4. That is 0.75. This is 1. So it comes out to be 13.75. This is the result in decimal. Hexadecimal to decimal conversion. After that, you need to convert this decimal to octal. So in this case, we are multiplying the integer part with the base and dividing the fraction part. बट जब आप अदर बेस टू डेसिमल टू अदर बेस जाते हो तो रिवर्स हो जाते हैं, जो आपके पास इंटीजर पार्ट होता है इसको क्या करते हैं हम, डिवाइड. सो आई वांट टू कन्वर्ट दिस टू बेस 8, so I'll be dividing 13 with 8. 8 से जब आपने डिवाइड किया, दिस इज डिवाइड बाय 1 and remainder is 5, so it is representing 1 5. Integer part is representing 1 5. Go to the fraction part, we have 0.75 into 8. So this comes out to be 6.00. Whatever is in the integer part will include that in the result. यहाँ से 6 आ गया, then is 0.00 into 8. That will always gives you 00. So we'll stop here. So this is in the octal. So again, it is coming out to be 15.6. आप जो भी approach कर रहे हो, that is fine enough. जिसके साथ भी comfortable हो, but I think method 1 is easier one. उसमें कोई मल्टीप्लीकेशन और डिवीजन नहीं है, जस्ट आपको बाइनरी बिट्स को रिप्रेजेंट करने, राइट. सो जिन लोगों ने मेथड 2 फॉलो किए, दैट इज आल्सो फाइन, बट आई विल रिकमेंड यू टू फॉलो मेथड 1. ऑलराइट, नेक्स्ट वन. In computers, subtraction is generally carried out by. When we talk about the arithmetic operations, that means signed numbers will be there in computers. What should be the answer? Read the statement carefully. You will get the answer easily. No calculation is required. In computers, subtraction is generally carried out by 1's complement, 10's complement, 2's complement, and 9's complement. What should be the answer? Very good. It's 2's complement. सबसे पहले स्टेप में हम 10's complement और 9's complement को रिजेक्ट कर देंगे. रीजन इज कंप्यूटर्स की बात कर रहे हैं. कंप्यूटर्स किस पे काम कर रहे हैं? कंप्यूटर्स आर वर्किंग ऑन द बाइनरी नंबर सिस्टम. Binary number system. Binary number system means basis 2. Means basis 2. Agar base 2 hai, then we can find only 1's complement and 2's complement. I hope that you remember the concept of radix complement and diminished radix complement. So it's 1's complement and 2's complement. तो computer system में आपके पास 1's और 2's complement use हो रहा है. So 10's complement and 9's complement हम find कर सकते हैं, but in computers it is not used for the arithmetic operations. 1's and 2's complement. Now, problem with the 1's complement. In 1's complement we have one problem, that is there are two different representations for 0. There are two different representations for 0. Now question arises is कि उससे हमें क्या ही फर्क पड़ता है? So can you tell me that क्या फर्क पड़ता है? There are two different representations for 0. क्या फर्क पड़ता है? Obviously बात है कि रेंज में फर्क पड़ेगा. For negative number, for the representation of signed numbers, we are using the complement representation. So we have 1's complement and 2's complement. We know that the range, because we have two representations for 0, तो इससे range में difference आएगा. Range for 1's complement is -2 raised to power n minus 1. n minus 1 इसलिए कर रहे हैं कि अगर आपके पास n bits हैं, 1 bit is representing the sign bit. So remaining bits are n minus 1 bits. So combinations will be 2 raised to power n minus 1. Because we are starting from -0, so -1, this is the maximum value you will be getting. 2 plus 2 raised to power n minus 1 minus 1. We have two different representations for 0. So that is why it is not correct. So answer is 2's complement. In 2's complement, this problem is removed. This drawback of 1's complement is removed in 2's complement representation. Can somebody tell me that what is the range for 2's complement? We just have one representation for 0. Obviously, signed numbers and so remaining bits will be n minus 1. So range for 2's complement is, although in this question it is not required, we have already got the answer. That is option 3. Since there is no negative 0, so range is 2 raised to power n minus 1, 2 plus 2 raised to power n minus 1 minus 1. I took the example with 4 bits. With 4 bits, it was coming out to be minus 8 to plus 7, right? So this is option 3. It was very simple. So in this session, we will be just discussing these many questions. आई होप अब आपको एटलीस्ट आइडिया हो गया होगा कि किस तरीके के क्वेश्चंस पूछे जा रहे हैं, किस तरीके से आपको हैंडल करने हैं. सो फ्रॉम नेक्स्ट सेशन ऑनवर्ड्स, कल वाले सेशन में हम काउंटर्स का क्वेश्चन, आई विल बी इंक्लूडिंग द क्वेश्चन फ्रॉम काउंटर्स. एक क्वेश्चन होगा जो हमने कल डिस्कस किया था, आपको बेस भी दिया था, उसके लिए आई हैड डिस्कस 2 मेथड्स. अगेन आई विल बी डिस्कसिंग दोस 2 मेथड्स, बट इफ यू गेट द टाइम, तो ये जो वीडियो होता है, दिस इज अ शॉर्ट वीडियो ओनली, सो जस्ट गो थ्रू इट. उसमें भी कुछ क्वेश्चंस है and definitely you'll get that. Okay, so currently those who are not enrolled in the super coaching, अब आप सोच रहे होगे कि मैम जो आप बातें कर रहे हो ये हमने डिस्कस किए है, कहाँ पे डिस्कस किए? दिस इज इन द सुपर कोचिंग बैच. So super coaching is a batch where we are covering all the subjects, all the units of both the papers, paper 1 and paper 2, in the live sessions, and currently the sale is going on. So today is the last day for the sale, so you can take the benefit. If you want to get enroll yourself in UGC NET batch, then you can get the subscription for only 6685, and this will be valid till your exam. For this, in order to get the benefit, you need to use the code, and code is Shefali S. All right, and definitely this is a limited time offer. And with this, obviously you will be able to access the test series, or practice के लिए test series को attempt करना is really important. So we have a good set of questions included in the test series, so you can go through it. In the next session also, we'll continue our discussion with the concepts through questions. I'll be taking the questions from unit 2 only. So next, approximately 10 sessions will be on unit 2, then we'll go to unit 7. Okay, unit 2, because this is the sequence that we are following to cover our subjects. So I'll be taking the questions in the similar order. Okay, any doubts or queries? This is all from my side. If you guys have any doubt or query, be it related to super coaching, then for to get to know more details, just follow the link which is given in the description box. So link is there, and in order to follow the Telegram group, again the link is in the description box. Those who have not subscribed the channel, to get more videos, please subscribe the channel and obviously like the video, and in order to get the notification, don't forget to hit the bell icon. Let me tell you that how we are covering the syllabus in the super coaching. I'm just giving you the overview. So there are 2 papers. We have paper 1 and paper 2. So for paper 1, daily we are having the session at 12:30 in the noon, from Monday to Saturday. Monday to Saturday. And for paper 2, we are having 2 sessions every day, one in the morning and other one in the evening. In the morning, we start session at 7:30 a.m. Duration of each session is 2 hours. It goes up till 9:30. And in the evening, it's from 8 p.m. to 10 p.m. Weekends are not off, because I know that you guys are free on weekends. You don't have any office, college, or whatever you guys are doing. So for morning sessions, there is Thursday off. एक ही दिन पूरा off ना लेकर, we have divided this Thursday off, and for evenings it's Monday and Tuesday off. Monday and Tuesday off. Apart from this, we will be meeting on YouTube. So I'm taking the YouTube sessions in the evening at 6:30 p.m. Short sessions. So again, here Monday and Tuesday is off. Saturday and Sunday, definitely yes, we'll be having this session. Apart from these questions, practice के लिए कोई book बता दीजिए. So you can refer to any book. Lot many books are available. You can take Truman, or I'll simply recommend just along with the syllabus, go through the previous papers and test series. This will be more than enough. Any other query? I hope, Shubham, I answered your query. All right, then I'll see you tomorrow in the YouTube session at the same time, 6:30 p.m. Keep on revising the concepts, and definitely जिन लोगों का revision अभी नहीं शुरू हुआ है, started from unit 2, और साथ साथ में हम questions करेंगे. अगर कोई concept छूट जाता है तो definitely I'll discuss the solution and that concept in detail in the YouTube session. Okay, thank you so much for joining the session. Take care. See you in the next session. Bye bye.